Now, guys, let's look at question 4. This is a little bit of a calculation question. You have magnesium carbonate reacting with dilute HCl, the equation given to you there. When 25 cm cube of this dilute HCl is added to excess magnesium manganate, volume of carbon dioxide at RTP is 120 m cube. Calculate the concentration in mole per dm cube of dilute HCl. So what are we given? Right, write it down. We're given HCl, right? Down 25 cm cube, given the volume. Then carbonate is in excess. Carbon dioxide that's produced is 120 cm cube. So what we want to do, right? We want to convert the volume of carbon dioxide to number of moles. Okay, so we convert it to number of moles by dividing it by the molar volume of gases at room temperature pressure, which is 24 um 24 dm cube. Okay, so 120 we convert it to dm cube first, dividing it by 100, and then after that dividing by 24, so we get 0.005. We'll just write it in, just take out this, we write it in 0.005 moles of carbon dioxide was produced from your carbonate. Okay, so they are asking us for the concentration of HCl, so we will use the mole ratio, right, of carbon dioxide to HCl. So it's 1:2 from the equation, 1:2. So number of moles of HCl will be 0.01, which reacted. And then this number of moles, if we divide by the volume, 25 over 1,000, so your moles over volume. Okay, so you just divide, you get 0.4 mole per dm cube. Okay, that is your concentration of your HCl. 0.400. Write that properly. 0.400 mole per dm cube. Okay, the reaction is repeated at a higher temperature. All other conditions stay the same. Using ideas about collision between particles, explain how the rate of reaction changes. At higher temperature, right, the particles will have more kinetic energy. So it means that more particles produce energy greater or equals to your activation energy. And then they move faster, collide more often, and there's more effective collision that gives rise to faster speed of reaction. Okay, what's the meaning of the term alloy? Okay, alloy means that there is a mixture of different metals with one or other elements. Okay, one very common example, right, is other than this one already given, is your iron with carbon. Okay, that is actually your steel. What is one advantage of using this duralumin, sorry. Okay, so if you look at all these component, right, you realize that aircraft, right, you want it to be harder, resistant to corrosion, and possibly lighter. Okay, so you can put all this down: harder, stronger, resistant to corrosion. Okay, to extract copper for the manufacture of duralumin, copper is required to be purified by electrolysis, construct the ionic equation. Okay, so at the cathode, right, you have copper 2 plus 2 electrons giving you copper metal. Okay, so this is the reduction that's going on.